Ready. Alright, so we're doing multiplying radical expressions. A little bit of review from grade 10. Let's take a peek. So we're going to be doing exactly the same thing with radicals, so we'll talk about it, but we'll just remember what FOIL is. I don't like FOIL. Okay? But what I like to say is, well, every term in each bracket has to multiply every other term. So this one has to multiply everything. So we'll do that right now. We'll get 9x squared, and then 3 times 1 is 3x. And then here, I'll switch colors because I'm fancy like that. Then the negative 1 has to multiply everything, so like that. So we'll get a negative 3x, and then we'll get a negative 1, and then we can clean it up. So what do we get? 9x squared. Those cancel out, positive 3x and negative 3x is 0, and then subtract 1, you're done. So we'll go through a similar process of expanding, grouping like terms, so that'll be last week's lesson, and then writing our final answer. The only thing I want to note on the last question, very common error, is to just try to raise, because you see the power of 2, people will raise this to the 2 and that to the 2. Just want to remind you that it's a binomial. So if you're squaring a binomial, it means you're taking the whole thing and multiplying it by itself. Okay, so really, that's the question. And then it would be identical to this process. So I think we'll just leave it at that. Okay? Hurry up, cheat. I'm going to keep going. Alright, let's rock and roll. So what does it look like for radicals? So here's some easy examples, and then maybe I'll go over the laws in a second. You simply, as long as the indexes are the same, so if indexes are the same, you multiply the radicands. You guys remember what the radicands are? Yes, so this is the radicand. Yeah. Indexes match, so I can rewrite this as the square root of 18. So there's an example. This one we could rewrite as the square root of 25. Now this one, check it out. Indexes match. Yeah? So it's the cubic root, so don't lose the 3. 9 times 6 is something. 54. There. Now, in a situation like this, where you're multiplying them, you multiply the coefficients. So this would be similar to having like 2x times 3x or something. So you would go 2 times 3 is 6, x times x, x squared. In this case, it's radicals. You go 3 times 2 is 6. And then because they have the same index, you can go 6 times 8, whatever that is. What's 6 times 8?
40.
Yeah.
Are we expected to break it down now? I mean, like.
Well, I should be really clear. You would not be multiplying these, like those coefficients, if the indexes didn't match.
No, but like, so now we ended up with 6 square root 48, right? Now,
Yes.
do we need to break down the 48 and bring out whatever numbers we
I'm just demonstrating to you how you multiply radicals. Yeah, like what we're doing is, like we're getting more complicated, so I wouldn't expect you to go back. Yeah. Okay. Last one. I guess there's really nothing new here. There's a negative outside. So, same thing. Then multiply those, negative 6, 12 times 24, whatever that is. If we, just to address your question, Kevin, if we were reducing, let's reduce this one.
Yeah.
So this time I'm not going to multiply them together because I don't want to make it more complicated. I'm actually interested in reducing and getting an answer. So then I'd be like, well, 12 is 4 times 3. 24 is, 4 times 6. Right, so I brought them in underneath the same, the same square root. And now I'm just going to say, oh, well, square root of 4 is 2. Square root of 4 is 2. So I'm going to go negative 6 times 4. And can I break it down anymore? What do you guys think?
Yeah.
Yeah, like 3. And then 6 is 2 times 3. Or 3 times 2. So now I can pull out a 3. So I got negative 6 times 4 times 3 times square root of 2. And then figure out what that is, and you got an answer, and you're done. What is it, negative 72?
Square root 3?
Square root 2. Right, we didn't pull out the 2.
Everyone's good? So yeah, normally you'd be expected to simplify. I was just trying to make them quick examples. Alright. That's really it. That's the lesson today. We'll do some distributive property with radicals. So now we'll use distribution. That really bothers me. Can you write the distributive property? So now we'll use the distributive property. It just says if you got brackets and a number outside, you got to multiply everything in the brackets by that number. So if it's a square root, no difference. So it's going to distribute inside. So you're going to have square root 3 times square root 6, subtract 3 times square root 3. Try to write the coefficient first. And then if you can simplify, great. So like the square root of 6 is the square root of 3 times the square root of 2. So you'll notice I'm doing this using that other property we learned a little while ago. So I'm writing it as separate square roots, but that's okay. So I got 2 square root 3's, which would give me a 3. So now I got 3 square root 2, subtract 3 square root 3. Are those like terms? No. So you would just leave it like that. If they were, we would keep going, but we can't. For B, we're still going to distribute in the brackets, but now we have a coefficient and the radical. Okay, so you'll be multiplying coefficients, and if possible, you'll be multiplying radicals. Okay, so 2 times 5 is 10. Square root 2 times square root 6, I'm just going to write it like that. Is that okay? Okay, alright, just making sure. 2 times negative 3 is negative 6, and then I'm going to write square root 2 times square root 2. Like that. Over here, square root 6, just remember, it's square root 3 times square root 2. So I'm going to have a square root 2 and a square root 2, right? Which is the square root of 4, which is equal to 2. Okay, so I'm going to have 10 times 2, 20. So now I have 20. And what's left over here? Square root 3. Just trying to save some time. Over here, square root 2 times square root 2 is 2. So I get subtract 12. 6 times 2 is 12. And then I can't go any further. Those are not like terms, so I'm just going to leave my answer like that. Why don't you try C on your own? Then I'll start writing the answer. There's lots of ways to tackle it. Like you could start breaking down the square root of 8 because you could simplify that. But honestly, for me, like I'm just going to multiply each term by whatever's in front here. So I'm going to get negative 5 and then times square root 2. I'm going to start breaking down the square root 8. It's square root 4 times square root 2. Negative 5 times negative 2 is positive 10. And then square root 2 times square root 2. And then 4 times negative 5 is negative 20. I'm going to recopy the square root 2, and then square root 10 is square root 2 times square root 5. So I'm just trying to do a little bit of work. Just give me a moment to catch up. I said I'd let you try it yourself, but then I didn't. It's typical Italian mom. You do it to yourself, and then they do it for you immediately. Alright, so square root 2 and square root 2 is 2 times negative 5 is negative 10. So I got negative 10. Oh, I forgot the square root 4. So I have 2 times 2. Okay, let me erase that for a second. Okay, so we have a 2 from those two things, and then square root 4 is also 2, so we have 2 times 2, 4, times negative 5. We actually have negative 20. Do we all agree? Alright. And then this is square root 2. This is 2. So 2 times 10 is 20, positive 20. And then over here we get a 2, so negative 40 square root 5 is what we have. Negative 20 plus 20 is 0. So overall, we just have negative 40 square root 5. Yay! And the crowd goes wild! I really don't like this stuff. It's kind of boring. Any questions?
You doing good? You get your jacket back?
Yeah,
Yeah, why do you have your jacket?
because we work together. So
Oh, you work together. That makes sense.
yeah.
That's okay. I don't want to know what you do. Okay, so a full expansion. All right, let's do it. So this is like that first example we did, but now there's some radicals involved. Guys, this is gonna be so fetch. Are you ready? I'm bringing fetch back. I'm gonna bring it back.
You know what? Sometimes I just block them out.
Oh, that's rich coming from you. Okay, let's do this. Let's do this. You don't block me out at your peril. I have 1 million views on TikTok, so right?
Stop letting that clout get you.
Yes,
Yes,
I am.
on TikTok.
What? I can't hear you. Can't hear your desperate cries for attention. Okay, here we go. So this times this. I'm comfortable just writing square root 9. Are you guys comfortable with that?
Yeah.
Okay. And then this times this, and that gives me a positive 3 square root 3. And then because I'm going to be so fetch, I'm going to switch colors, do this. Negative 2 times square root 3, so you get negative 2 times square root 3. And you get negative 2 times positive 3, so positive 6. Yeah. Alright, so we can clean it up. Let's see. This is 3, right? Square root 9 is 3. Are these like terms?
Yeah.
How do we, yes they are. How do we know they're like terms? Because the same?
Yeah, it's
Which one? This one? Oh, the last one. Yeah, it should be negative 6. Yeah. You guys finally caught it. It took you forever, but I did it on purpose.
Sure.
Yeah, no, that should have been negative 6. I knew that. Just making sure you guys are awake. So.
We all believe it.
Yeah. So we were just saying those are like terms because they have the same radical component, same index, all that stuff. So then we can write it as what? Plus square root 3, because negative 3 subtract 2 is 1, and then we have this negative 6, and we can go 3 subtract 6 is negative 3. The order you write it in doesn't really matter, so I could write it like this. Or you might have written it square root 3 subtract 3. It's fine. Same answer. Hooray! So I hope this stuff, like, it's like, if you know the rules, it's easy enough. I guess it's good to be able to manipulate these things algebraically. It's pretty freaking boring though. Okay. Let's try another one. Here we go. I'm gonna switch colors. Here we go. This one multiplies that one, and it multiplies that one. So we get negative 2 times 1, which is negative 2. And then we get square root 3 times square root 3, which is square root 9, which is a perfect square. And then we're going to go negative 2 times negative 5, so we get positive 10. What do we do with the square root 3? Yeah, just leave it there, right? It's just all being multiplied, so just make sure you carry it along for the ride. Right, there's nothing to multiply it with, right? As opposed to this one, we're able to multiply those together. Alright, so that mystery is solved. Now we're going to take the positive 2 and multiply it in. So we're going to get 2 times square root 3. And we're going to get 2 times negative 5, which is negative 10. And I did not miss the negative on purpose this time. Alright, cleanup crew. So square root 9 is 3. 3 times negative 2 is negative 6. And then these are like terms because they have the same radical components. I can go 10 plus 2 and get 12. Square root 3. We copy the negative 10. And then I can go, well, negative 6 subtract 10 is negative 16. So as long as you have a negative 16 in here somewhere, that's good. Again, just a reminder, you could have written it like this. So, we did 12, 12. There. Either answer is fine. Okay. Oh, there's so many more left and they're all the same. I don't think we need to do way too many of them. Well, no, we got to do it with variables as well.
So everybody's good with this?
Yeah.
Yeah, is that a question? What's the question? Oh, remind me, I have your quizzes, I'll give them back, yeah. I had them last week too. So I don't think we need to why don't we do D? It looks funny. Alright? Looks funny. Let's see what happens. Alright, here we go. Some fluff just came out of nowhere. Alright, here we go. This one times this one, this one times this one. So square root 5 times square root 5. I hope you're getting comfortable enough that you could just write, well, that's 5. That could save you some time, right? And then this one times this one is square root 15. And I decided to multiply them together because there's no simplifying I can do. Okay? Then I'm going to get negative. So this one times that one gives me negative square root 15. And then this one times that one gives me, what am I going to get overall? Does I get square root 9?
Yeah.
Which is?
Negative. No, it's going to be
It'll be minus 3. Right? Because I get this. I get negative square root 9 when I go this one times this one. So clean it up. This is 0, right? And then 5 subtract 3 is 2.
Yeah.
So are there any questions at this point? Everyone's good?
Yep.
Yeah, definitely do the practice, but there's really none of these questions. Oh, this doesn't really add anything. B doesn't add anything. There's a bunch of try it yourselves. Well, I can give you answers. How about I'll just give you the answers, and you can decide if you want to try them out on your own after. So this one you'll get square root 6. This one you'll get negative 13. I do recommend you try them out on your own. Just add them to your homework. So square root 6, negative 13, and then for these ones, which are just try it yourselves, for this one you get 14 plus 2 square root 10. So 14 plus 2 square root 10 for A, and then for B you get 20. Because now we're going to do the whole thing again, but with variables. So we'll focus a bit more on that maybe. Don't want this lesson to be overly long. Yes, sir?
Can you use formula x squared minus y squared?
Oh, certainly. If you're noticing that this is a difference of squares, right? Yeah. Okay. I'll quickly do B just because I think Shrey raised an interesting point. This will certainly save you some time. Now, guys, check this out. Oops. So if you're noticing, look, this is A plus B, right? So this and this are A, this and this are B. The only thing different is the sign in between them. So we know that this is equal to that, right? So if you take this and square it, it'll be 4 square root 2 squared minus, and then B squared. You should get the answer. So actually, this is great. How do you go? You go 4 squared is 16. And then do I have to square this too? No.
Because it's square root, right? So.
But yeah, I mean but I did square it. Yeah, so I get 2. Right? What you're doing is you're going 4 square root 2 times 4 square root 2. So 4 times 4 is 16. Square root 2 times square root 2, 2. Subtract 2 squared is 4. Square root 3 squared is 3. So you get 32. Subtract 12, which is 20. Okay? So yeah, if you notice it's a difference of squares, you can certainly use the formula for difference of squares and figure out the answer, maybe with less work. I don't know. I feel like there's just less chances of making mistakes. But I mean, it's a special case. They do like using it on the exam quite a bit, right? So, okay, let's do this, so take a moment to read through.
Wait.
Oh.
Yeah.
Yeah, it saves some time, sure. I'm not sure how much time. Yeah. Oh yeah, sorry. Of course. Okay. So just like last time, it's like, well, what if we start having variables under the radicals? Nothing changes, but now you're worrying about whether they're like terms for radicals, and then whether the things underneath are like terms and you can multiply or add them or whatever. So they show you an example of expanding this out. It's a difference of squares, and they actually go ahead and they use the formula like we just did. So that's actually pretty convenient that we noticed it. So yeah, what they do is they're like, well, this is A, this is B, this is a difference of squares, so it's A squared minus B squared, and they just pop it in. So 2 squared is 4, the square root of x squared is x, and there you go. Any questions? Super fascinating. I would say it's like semi-fetch.
You even do it well though.
Of course I do. I do everything well. Okay, let's take a look at this. The expression, right, is defined for any real number. Let's see. Oh, guys, are you reading what they cooking? Like, if you look,
teaching you these things.
I'm just making them up. If you look at this, you would say x is an element of the reals, right?
Yeah.
But you have to consider where it came from. So what are the restrictions here?
X and negative.
So x. You're right. Okay, so this restriction still exists. So even though this looks okay, the restriction is still x has to be greater than or equal to 0. Okay, so that's what they're saying down here. They're saying, well, that's still the restriction. Okay? So the conclusion, if you want to highlight this, the restrictions on the original, the original expression are going to exist at the end of the question. Even if it doesn't look like they do, right? If you just look at this, you're like, well, there's no problem plugging in any real number. But because it came from this and then you simplified it, you need to keep that restriction. So we'll be doing that for every question. Here we go. It says identify the values of the variables for which each expression is defined, and then expand and simplify. So the first thing you should do is look at your expression and give your permissible values. So a has to be greater than or equal to 0. Is there anything else? Nope. So now you can expand it. It's a difference of squares again. So we could use a squared minus b squared. I'll do it for this example.
No, it is
Oh no, sorry, it's not. Yeah, you're right. Why isn't it? Well, because this and this are different. Those are different. There's lots of reasons why it isn't. Yeah, when you I was not looking very carefully. I just saw the plus and minus. Yeah. Yeah, make sure you give lots of reasons. Okay, here we go. So we'll just expand it out. So this times this times this. So 3 times 4 is 12. And then when you multiply these together, be careful. Like these are like terms a and a, so we can write a squared. And then this one times this one, so 3 times 5 is 15. And we just keep the square root a. Comes along for the rise. Now we're going to go negative 2 times this one, so we get negative 8. Square root a, and then negative 2 times that one, we get negative 10. Right. So the square root of a squared is a, so we get 12a. And then these two things are like terms because they have the same radical component. So we can write 7 square root a, and then subtract 10. And I don't think there's anything we can do with that. There's no more like terms. 12a, 7, the square root of 7a, or 7 times the square root of a, sorry. So all we got to do is recopy our restriction. We need to see it on the last step, and you're done. And we can do another one, and we can do another one. And we're almost done. I think there's just a few more examples. Everyone good? No questions? Okay. What about this one? Okay, this one's got lots going on. This is a difference of squares, yeah? Right, because this and this are the same, and this are the same, and it's plus or minus. So I will be using a squared minus b squared to save time. And then this one, we have to be careful that when we write it, that we remember that squared means that we're going this thing times itself, right? So I'm going to sort of write over it. Don't write over it in your notes. Maybe on the next line, write this. I'm just lazy. You want to be able to see that it was squared, and then this is how you handled it. Okay? Guys, my kid is getting really lippy. I made him a fort in the basement because he's got like this big castle with balls or something in a slide. So I put like a big blanket over it and a bunch of pillows in there. And then he took my cell phone, and I think he figured out the password. He's really good with numbers. So he typed in the password, and then I was like, "Where's my phone?" Like I was just like asking the room, and then like he slides down the slide, and he's like, what does he say? He's like, "Daddy," he's like, "I have your phone," and I was like, "Oh, like well, where is it then?" And he's like, "I don't know, but you don't need it," and then he like walked out of the room. I was like, it's the strangest thing I ever seen in my life.
This guy asked you what inspired you to tell us that story right there.
I don't remember. I don't know.
It's like I need it.
Everyone's ready? Guys, we keep forgetting to do the Larissa test. Right? We could ask her, she's right there. Be like, Larissa, do you care? Did you care about the kid story? Oh, she's thinking no, but she's like, if I say no, I'll look mean.
This is good. This is progress.
It's okay. Alright, here we go. This one times this one gives us, I'm going to write all my words. So I'm going to write this. But I would be totally fine if you went straight to that, eh? Okay? But that's what you get. And then this one times this one. So, x and y are not like terms. So all you do is write them underneath the square root together. I recommend that you write them in alphabetical order. Because if you get a square root xy, and then you get a square root yx, are they the same thing?
Yes.
They are, but is it possible that you might look at them and be like, oh, but they look different and they're not? Right. So that's why if you're just in the habit of writing them in alphabetical order, they'll all be in alphabetical order and they'll all look the same. I mean, if they are the same anyway. Okay. So we did this times this times this. Now we're going to go negative 2y times that one. So here it is. If you just write them in the order you get y times x. And then you might think they look different. So if you write them in alphabetical order, though, you'll be much happier when you get to the simplifying steps. I said I was going to go a squared minus b squared, and then I didn't. Anyways, this one times that one gives me negative 4. And then y times y, I get y squared underneath the square root. You could. Yeah. Now I completely run out of room for this one. So I'm going to see if I can make it fit. But this times this is 9. This times this is x squared. And then I got this one times that one, so plus, oh no, did I forget one? I did. This one times that one. So I get 3 square root xy, and then I get another 3 square root xy, and then this one times this one, y squared. There. I'm just showing all my work. Alright, so now, square root of this one gives me x. These are like terms right here. So they happen to have the same coefficient, so you'll cancel out to 0. This one here, I'm going to get subtract 4y. And then I'm going to get a 9x from that one. And over here we got 2 like terms, so same radical component. So we get 6 times square root xy. And then the square root of y squared is y. And now I'll see if I have any other like terms. So I got an x and a 9x, which gives me 10x. I'll just underline them so I know I did something with them. I get negative 4y plus y. So I get negative 3y. And then there's nothing I can do with this radical. Okay. I'm done. Have I forgotten anything?
Your restrictions.
Yes, my restrictions. So if we go back to the beginning, on the x I have to be greater than or equal to 0. And then on the y I also have to be greater than or equal to 0. And that'd be all the restrictions. You gotta check them all though, but. There. Well, that question was a nightmare. There. I don't think we need to do the last one. I'll give you an answer. I'll give you an answer in case you want to try, but I feel like we've done enough. I was giving you guys time for the mental math.
We're keeping this for a month and a half. We're going to carry on keyboarding this semester, but you should still be present for the class.
Guys, I was staring at you guys from the window.
Yeah, but what were you doing? What were you doing? Just
Ask too many questions. Everybody got the answer?
No.
Exercise 40?
That was your quiet session. No.
Bye bye.
Do it first time.